Welcome back, everybody. We are in part 3 of the third chapter, chapter 3, and we're going to check out measures of relative standing and box plots. Box plots will be the last thing we do. We're going to start with a Z-score. Is the number of standard deviations that a given value X is above or below the mean. Z-score is calculated, and this formula is important. It's going to be the data point minus the sample mean divided by the sample standard deviation. And if we have the population information, we use it instead. And I want to be clear on this, that from here to here, between plus or minus 2 standard deviations, this is the usual zone. And outside of that is the unusual zone. Unusual. And sometimes we're more interested in the unusual cases because we want to know, hey, how did they become so unusual? Whereas the boring ones tend to be captured within here. This also will signify that 95% of the information based on the empirical rule is between -2 and 2, and outside of that is going to be the missing 5%. All right, let's do an example. When Steve Jobs was CEO of Apple, earned an annual salary of $1, the CEOs of 50 largest US companies had a mean salary of $1,449,779 and a standard deviation of $527,651. And we're going to convert Steve Jobs' salary into a Z-score. And so it's 1 minus the $1,449,779 divided by 527,651. So let's see what that turns out to be using a calculator. We're going to go 1 minus 1,449,779 divided by 527,651. There we go. Gives us a Z-score. It's negative in this case because it's obviously his salary is a lot lower than most of these executives. And I'm getting a negative 2.7476. And because that's outside of the plus or minus 2, so we're over here, this is considered unusual. And we certainly, as common thinking people, understand that $1 a year salary is unusually low, if not insane. So some properties of Z-scores. We have a Z-score are expressed as numbers with no units, meaning if the original data is in inches or centimeters, the Z-score itself has no unit at all. It just tells us how many standard deviations away from the mean it is. If an individual data value is less than the mean, then the score will be negative. We've just experienced that, or it was less than the mean. All right, now we are to the second big deal of this particular section, and we're going to talk percentiles. Our measures of locations, and they're denoted p sub 1, comma, p sub 2, comma, up to p sub 99. And the subscript here represents the percent of data that is below that given location. That's basically what everything says down here. We have a nice graphic that sort of explains that. P sub 2 represents the bottom 2%, and p sub 98 represents the top 98%, or the top 2%, however you want to view that. Moving on. And we'll clear up some notation here. N is the total number of values in the data set. K is the percentile being used. That's the subscript. That's the percent that's below. We have L, the locator, that gives a position. And P sub K, where K is the percentile. We mention that up there. And P is the kth percentile, pardon me. And example 12, we have 3 parts to this. Here we have some data. This is 50 airport data speeds. This is for internet use. And we're going to start out with find percentile for the data speed for 11.8. Now, 11.8 is here. Now, there's 10 across. So this is 1 through 10, 11 through 20, 21 through 30, and so on, all the way up to 50. And so in this particular case, we are going to have that, and we're using this formula here. The location in this case, what we want to know basically is how many data points are below the 11.8, where there's exactly 20, right? 10, 20. So this is going to be 20 out of the total of 50. That's what this formula is saying. And then we're going to multiply it by 100 to make it a percentile. So 20 divided by 50 times 100, pardon me. And that gives us 40. And what that means is this is 40. Piece of 40 is 11.8, meaning 40% of the information is below the 11.8 marker. That is the guarantee. And now we're going to go in the other direction. Let's keep the data up for both. Find the value of the 25th percentile, meaning I want to know the location of the piece of data where a guaranteed 25% of the information is below it. That means I need to find 25%, 25 over 100, which is 25%, out of the 50. So 0.25 times 50. 12.5. Now you'll notice we have a decimal on this one, which is good because we are always going to round up in this case. So this is the 13th position. Is going to guarantee us that 25% of the data at least is below it. So 1 through 10, 11, 12, 13. 11, 12, 13. So piece of 25 is 7.9. And again, we always round up. Now here's the thing. If there's nothing to round, then we have a problem. Because if it's an even whole number without a decimal, we're going to have to do some fancy tricks. Which brings us to our last example here. Find the 40th percentile. So L is going to be 40 over 50 over 100 times 50. Let's see what that looks like. So 0.4 times 50. All right, we have a whole number now. That's going to create a problem. The 20th position is our 11.8. Actually, it's 11.6 is the 20th, right? 1 through 10, 11 through 20. There's our 20th position. Because it's a whole number, if I look at the amount that's below it, that's not 40%. So what I'm going to have to do is I'm going to have to take the 20th position and add it to the 21st position and find the mean, find the average. So let's see what that looks like. Here's the 20th position. Here's the 21st position. I'm going to find the average. So this is that piece of 40 is 11.7. We only have to do this wacky trick when we get a whole number, which usually doesn't happen. Usually we get a decimal and we just round it up. All right, we are moving on to quartiles. We like quartiles. We're gonna have some fun with it. Quartiles divide data sets into fourths, or equal parts. And we're gonna run one var stats to get our 5-number summary. And I'll do that in just a moment, which makes up the minimum. So here are the 5 parts, 5 numbers. Minimum, q sub 1, that's the first quartile. The median, which is q sub 2. Q sub 3, and the maximum. So there's the 5. 1, 2, 3, 4, 5. The interquartile range is the middle 50%. So that is going to be literally, so when we have our data, here's our 5 pieces. Our interquartile range is there. I, Q, R. It's the middle 50%. And to be clear, Q sub 1 is actually P sub 25. It's the percentile. The median is another 25%. So that's going to be P sub 50. Another 25% of the data, and the last 25% of the data. And what we're going to do is we're going to come up with our IQR, that's the middle 50%, Q sub 3 minus Q sub 1. The lower fence is going to be Q sub 1 minus 1.5 times the IQR. Upper fence is going to be Q sub 3 plus 1.5 times the IQR. Now, our upper and lower fence are going to give us what we're going to accept. If we have something less than the lower fence or bigger than the upper fence, it's going to be what we call an outlier. Example 13. Now I have already entered the data into my calculator. Here we are in L1, 31, and so on. And we are going to come up with the quartiles, the IQR, and we're going to check for outliers. So here's how I'm going to do that. After you enter the data, you may need to pause the video to put the. I'm going to go to stat, calculate one variable statistics, and my data that I'm interested in is in L sub 1, which is above my 1 here. So I'm going to hit second in L1, and that changes it to L1 here. You may have a different calculator that has a different interface. You would just do one var stats and then type in L1, hit go. And it doesn't look like we have the mean, we have the standard deviation and so on. But if I scroll down, it has my 5-number summary. The minimum, the Q sub 1, the median, the Q sub 3, and the max. Let's write those out. And they're going to be, use this, 31, 56, 72, 83, and 99. All right, so now let's find, there's our quartiles, we have them there, our IQR. That is going to be 83 minus 56. 83 minus 56, 27. Cool. So let's find the fences now. Lower fence is 56 minus 1.5 times 27. 15.5. Our upper fence is going to be 83 plus 1.5 times 27. And I'm going to look at the data set. Do I have anything smaller than 15.5? Nope, the smallest I have is 31. So we're good. Do I have anything bigger than 123.5? Nope, the biggest I have is 99. So in this case, there are no outliers. All right. Now, if we want to graph this data, we could do something called a box and whisker diagram. They're called box plot now. It's when I was in college, they called it box and whisker, and I will show you what that means. And we can actually draw this. And I could put, let's see, 30 here, 40, 50, 60, 70, 80, 90, 100. And so here is our box. We have 31, which is way over here. Put a dot there. 56. Put a dot there. 72. Dot there. 83. And 99. Dot there. Yep. Dot there. So here's how this works. Here's our box portion of it. And then we have the whisker portion of it. There is our first box plot. And we'll talk more about how that's skewed or not skewed here in just a moment. Let's do another example. Here we have data representing hemoglobin for 20 randomly selected cats. And we're going to do a few things with this. I've already put the data into my calculator. I'm in list 2. There's my 5.7 and so on. And we'll start out with part A. Find the Z-score corresponding to the cat with a hemoglobin of 7.8. So here's part A. Z is 7.8 minus, and what I'm going to do is I'm going to run one var stats on list 2 to get the mean. And now I need list 2. Just remind you how to do that. That's above the 2 button, so second 2 for list 2. And you can see I have list 2 now. And the mean in this case is 10.08 divided by the standard deviation, which is here, 1.8858. Let's see what we get. 7.8 minus 10.08 divided by 1.8858. The Z-score in this case is about negative 1.209. So there's our Z-score. Determine the quartiles very nicely. I can just run this again on list 2. So let's run our, so part B, so minimum, Q sub 1, the median, Q sub 3, and the max. And I got 5.7 is the minimum right there. 9.15. The median is 9.95. 1 and 13.4. All right, part C. Let's find the IQR. Remember that's Q3, 11.1 minus Q sub 1, 9.15. Part D is we're going to determine the lower fence, which is the 9.15 minus 1.5 times 1.95, right? So it's Q sub 1 minus 1.5 times the IQR. So 9.15 minus 1.5 times 1.5. So we're getting 6.225. Upper fence is going to be Q sub 3, 11.1 plus 1.5 times the IQR. And now we're going to determine if there's any outliers. Are there any data values that are less than 6.225? Yep. Look at that. 5.7 is an outlier. The next one up is 7.7. Is there anything bigger than 14.025? Nope, we're good. So 5.7 is an outlier. And we're going to make a modified box plot. Let's get that up a little. All right, so we'll say this is 5. And we have to go all the way up to 14. So 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, those don't look evenly spaced to me, but we're going to have to make do. All right, first let's start with our outlier. That's 5.7. What we do on our modified box plot is we put an asterisk saying, hey, it was a data point, but we're not including it in our graph. Here's the thing. 5.7 is out. That means the min now, the minimum, is no longer 5.7, it's 7.7. That's now my smallest point. And now I'm going to use my Q's here. So 9.15, and then 9.95. And then 11.1. And then lastly, we have 13.4. So there's our modified box plot. And I want to point out that we have some information about what this graph looks like. Do you see it's a little skewed right? Because the bit closer to Q sub 1 than it is to Q sub 3. So we would say it's skewed right. For the other graph, it goes the other way. So it's skewed left, just slightly. And that is percentiles and quartiles. Take care.